your time for this webinar. On behalf of the IEEE Iran student branch, I'm glad to welcome our keynote speaker, Dr. Ismail Essackjee, who is a senior engineer with over 15 years of experience at the Central Electricity Board. He is also a researcher in the field of renewable energy integration, as well as a certified coach. Today's topic for his presentation is the contribution of Gen Z engineers in the realization of power system transformation. Before I hand over the stage to Dr. Ismail, let me brief you how the webinar will be conducted. If you have any questions during the presentation, just write them to chat, or you may note same for a question and answer session that will be provided at the end of the webinar. I would request all of you to be interactive, as this is an opportunity to enhance our knowledge. Thank you very much again, and it's over to you, Dr. Essackjee.
Thank you very much, MC. Thank you for this opportunity, giving me to be presenting such a maybe interesting topic. It has been interesting for me during the preparation itself, because I had been thinking about it for quite some time, but I had to put everything together. And I hope I will be maybe meeting your expectation like for this 40 minutes or so, which is coming up. So let's get started. So the title itself is quite intriguing, okay, because we are talking about Gen Z engineers. And I presume that most of you, maybe the majority of you who are listening, who are attending this webinar, are still students, and maybe in engineering, you're studying power system, maybe even IT, software engineering, things like that. So how do you fit in the power system, maybe scenarios, the landscape that we have for the power system? So let's get started. So what is, before just getting into the main part of the topic, let's maybe familiarize ourselves with what we mean by the Gen Z engineer. It's not about the Z transform or things like that, that you're going to do maybe Fourier analysis and so on. So it's about the generation that you as student, current student at the university, you form part of this generation. But let's have a look, let's differentiate between maybe the different generations that are maybe in the workplace already, or who you will be meeting when you're going to join the workplace shortly after. So we have the baby boomers that is born in between 1944 and 64. So let's compare that with the maybe a familiar way for you to understand it. I've tried to relate it to music. So baby boomers, they were maybe listening to this kind of music, okay, and this type of equipment they were using for, I don't know if you know this type of equipment, but it is there and they have been using that maybe too. I've seen some of these equipment, but I've not used them myself. So these are maybe form part of the baby boomers generation. Then we have the Gen X in between 1965 and 1979. So they were maybe using the cassette tape. I'm familiar with that because I'm maybe an early millennial, but then those who was a Gen X, they were using, like, it was commonplace for them to be listening to music in terms of cassette. And this was a craze at that point in time. Then we have the millennials. Maybe I'm part of the millennial, maybe some of you as well. And for us, it was a MP3. Okay, we had part of the cassette as well, but most like the near like 15 years or maybe slightly more, 20 years back, we were introduced to MP3 and we could download, we put on CDs, we put on Walkman, on CD-man and things like that. So we were the MP3 generation. Now, how about you? Okay, I'm speaking to all of the students mainly, so Gen Z engineers, that we call the Gen Z. So you were born between 1995 and 2015. So for you, it's about streaming music, maybe listening to Deezer, YouTube, and so on. So you can see in terms of the music itself, only one item, one topic which we are choosing. There's a variety, like you're going to think differently. You're going to maybe there's another maybe example which I usually take, which I've seen a video on that. When you ask, maybe if let's say you are in the middle age and you like 40 years, you try to get an adult, maybe not an adult, but maybe a grandparent, to tell them, okay, how do you take pictures? Okay, just show me with your hand, how are you going to take pictures? He or she's going to take you to show you the traditional camera, okay, with the fingers, and he's going to click it with his second finger. But just ask maybe a kid okay, or maybe 3 or 4 years old, just show me how you're going to take a picture. He's going to show you he's taking a picture with a mobile phone. So it's a generation gap, or it's a paradigm shift, but it is what we need to know. It's normal. It's part of evolution. And now, so we are going to speak about the Gen Z. So what is so special about the Generation Z? Okay, so that we are having a topic, a special topic on this slide. I don't know if we have, I think I've just got a note, we have 10 minutes only remaining. I don't know if we are going to be shut off after 10 minutes. Okay, let's see.
We'll use the same link again.
Okay, no issue. So after we got disconnected, we are going to just reconnect back again. So for the Gen Z engineers, so what's so special about you? It is each generation actually, like my parents, how they thought about me, my grandparents, how they thought about my parents. So each generation believes that the generation coming after them are doomed. Okay, maybe if you are having some lecturers here, they will tell you, okay, this generation that you are is doomed. You can't actually do things that we are telling you to do things like that. You are doing it in a different way. So this is maybe how they are going to maybe see things. Okay, same for my parents. When I was using the internet and 20 years back, okay, we're using the dial-up approach. Okay, we need to dial in 3121212, then telco, username, telco, password, telco, and then we had to wait for the dial-up to get the internet connection and so on. So things have changed nowadays. So my dad was after me, okay, so I think we had only like 20 hours over a month. So I was always like going above this 20 hours. So maybe he always told me, okay, I'm going to shut down the connection. Not going to pay. I'm going to disconnect the internet connection, but he never did it. And this was my generation that we were learning about internet and so on. So we just managed. So as parents nowadays, or maybe, so it is about understanding the different generation. It's not that we are the best generation, the one coming after us are doomed. It's just that we need to understand that it is part of evolution. So we had the hippie generation in the past with passive resistance, non-violence. And so anyway, what's important here is to properly understand that we need to adapt to this trend. Okay, they are here. We can't change this new generation. It is part of maybe social effect, political effects, and so on, so that we call them a generation. So if you have seen the slide previously, it's going to be like within 15 and 20 years, what we call a generation. It depends. So within, maybe the one introduced me, so the girl who introduced me, she said that I have like 15 years of experience in the power system. So it is like a generation. So I'm maybe moving away now, maybe to another step, but who is going to fill in the blank now? Okay, it's about the I'm from the millennials. It's going to be the Gen Z who are going to step in the power system for things to move forward. So initially, the Gen Z were called the selfie generation, as you may know, selfie, or the iGen generation. There are some books which have been written, they call them the iGen generation. But let's try to understand what is meant, what is maybe some important characteristic of this Gen Z generation. So it is a first generation of 100% digital native. So you are 100% digital native. I have seen maybe transformation, okay, but those who are from the Gen Z, they're 100% digital native. So what is meant? Okay, maybe those who were born in this maybe era. Okay, let's call that the era. So like the doctor is saying, there was no umbilical cord. These days, babies are connected by Bluetooth. There's no umbilical cord for them to be cutting and so on. But let's see what are some of those important characteristics. First one, they had their first mobile phone at 10 years. Maybe nowadays, it's slightly maybe before their first mobile phone. They're hyper-connected world. Why am I highlighting some of these characteristics? Because we are going to see how you are going to use these, and these are going to be so important in the new trend of power system. Okay, it is maybe people may be looking at it, oh, you spend so much time on being connected, so much time on networks and so on, but these are going to be important things for you to use. Okay, these are going to be maybe assets, okay, strength factors for you to be able to adapt to the power system, the new trend that the power system is taking. So it's hyper connection, communicate with videos and images. So as you have seen, I don't know how many of you still read the traditional newspaper, okay, that you need to go to the newspaper seller, buy it, and then maybe fibbling through the different pages and so on. There are some people who do it, but the new generation, do you do it? Or maybe you can just have a look at, you got it on soft copy on your mobile phone. You're just going to run through it very quickly, maybe 1 or 2 articles which are going to be interesting for you. You're going to read it, or you can access the link maybe from Facebook or from the website itself. So it's about a generation shift as well. Maybe if you use Facebook a lot, you have seen maybe Facebook basically when you need to write maybe, so we have reached 32 cases, new cases of COVID-19 today. So you're just going to write that. The impact is going to be quite low. But if you use nowadays, everyone has an avatar on Facebook. So you write the avatar, maybe it is happy, a bit sad, a bit waiting. So it's going to change. The response is going to be different. So why? Because you're communicating with image. Again, if you communicate with video, short videos and so on, it's going to create it's going to be like impactful when you're going to use image and videos. And see more, so like 73, like 3/4 of the Gen Z are worried about the planet. So what is meant by they're worried? They have a strong maybe willingness to do things which are sustainable. We are talking about green energy. So they are worried about getting like maybe doing things which are renewable, use renewable energy. We are going to come back to all these later on in our discussion. We are going to merge it. We are going to integrate it with the requirement, the new requirement, the new world order of the power system coming up. And next, let's see, 80% receive most information from social media. So it's not only the Gen Z. Okay, they are characterized by these different maybe things we are seeing right now. But then there are some people like maybe myself, I get a lot of information from social media. Okay, so it's not a clear cut, okay, I'm millennial, you're Gen Z and so on. There are some things, some ways by which we can like overlap. We are more maybe adapted, we can adapt to the situation, but then we'll see that there are specific point, I can't like go over certain barriers. We are going to come back to that later on. Let's continue slightly with a few of the characteristics of Gen Z. 75% say college isn't the only path to good education. So there are other ways of good education. You can have longer path to education. No need to go through the current systems that we have. So I think we already believe that this system is not the only one best solution that we have. So there are other things that we can use, like we have so many part-time courses you can see nowadays at the university. So we can see it's not like only one approach to education. There are many, and the Gen Z believe that it is the only. So like 75%, 3/4 of you share such a belief. 28% more able to buy products via their mobile phone or cellular phone. Okay, so buying online and so on, maybe not even online, it's not on the PC, the laptop, it's about buying on their mobile phone. So you are more up, you embrace change. Okay, you have this credibility, you have this trust in your mobile phone, in the network, in the payment, and so on, to be able to move things, make things happen for you. So 25% spend, that is of the Gen Z, spend 5 hours on their mobile phones daily. And in this confinement, maybe this can go slightly above as well. The Gen Z has some amazing abilities to bring together information, process it, and take action. Okay, these are some of your abilities. Gen Z has a strong ability to adapt to change. So we are going to use all of these later on when we're going to describe what we mean by the Gen Z, how this Gen Z, Generation Z, is going to adapt. Not only adapt, the power system will be needing such maybe engineers, people with such characteristics. So basically, this is our introduction. We have the traditional power system, which we are going to describe in a short while. And then we have the Gen Z. Will this generation fit in the traditional power system? So what is meant by the traditional power system? It is reliability, security of supply, and then quality of supply. Let me just check the chat. Okay, so we'll be disconnecting in like less than 1 minute. So use a link again, we just reconnect. I'm just completing this part. So we are discussing about, will this Gen Z be able to connect to the traditional power system? characterized by reliability of supply, security of supply, and quality. So let's disconnect and then let's reconnect after maybe a few seconds. See you in a short while. Okay, let's continue with where we have reached. Hopefully everything is going to be fine. Yeah. So we were speaking about the introductory report was about the Gen Z, the generation, what characteristics they have, how they behave. Okay. Now let's consider the traditional power system. This is like an overview of a power system, the traditional one. This has been taken from the annual report of the CB. So let's go quickly through that. We have the generation part where you have the centralized power generation, mainly in Port-based, and we have independent power producers as well at different instances over the island. We have the transmission network over lattice towers, basically at 66 kV. Check the chat. There's no sound. It's good. Okay, that's good. Let's continue. So we have the generation, we have the transmission part. Following that, we have what we call the distribution. So like transmission is 66 kV, then we need to distribute to different load centers. Okay, so then it's going to be on 22 kV. And then we have distribution, we have first level distribution, which we call the primary distribution, like 22 kV. Then we have the secondary distribution, where it's going towards the houses, like 400 volts for three phase, and then single phase, it's going to be like 230 volts. So this is a distribution type part. And then after then, like the final part is about the customer and all the power system. We have the residential, commercial, industrial, and the different loads that they share. So what is the flow? The power flow is from generation. We have only like a unidirectional power flow from generation through transmission, through distribution to the customer. What is a data flow? What is the sharing of information that we have? So it's from generation to transmission. So we have like an online SCADA, which is going to monitor the transmission system as well as the generation, like the power plant, to be able to share, to understand what's happening and so on. So it's limited to generation and transmission mainly. How about payments? So payments is done from the customer to the, maybe we call that the generation, but in Mauritius, it is integrated generation, transmission, and distribution. So it's going to be towards the utilities, a customer paying the utility. So this is a traditional, what I'm like calling the traditional power system. Let's see now how things are going to change. Let me see if I miss anything. I think should be fine. So now it's not only you're not going to listen to me, you're going to work on a small, maybe activity that you are going to do on your own, each and individual, like it's going to be an individual work. And let's see, so you're going to have a SWOT analysis. I don't know if you have learned about the SWOT analysis. So you're going to identify your strength, your weaknesses. So strengths and weaknesses are internal to you. It's like individualized, it's for you. Then we have opportunities and threats. So these are external to you, like external environment. So here, I wait for today, strengths and weaknesses are going to be your like how you're going to say, okay, this, I think I can do that. I think I have these skills. So these are going to be strengths for you. Oh, I don't know how to do that. So I need to learn that. So these are going to be your weaknesses. Opportunities. Oh, so this power system, they will need these skills in the power system, and I have this skill. So this is going to be opportunities for you. So threats is going to be, okay, they will be needing such maybe skills, or this is how things are being developed, but I don't know, I've not been used to that. So maybe this is going to be a threat. So then we are going to do a matching exercise of the end. So for you right now, you will need to get maybe a piece of paper, pen and pencil, just to write out, note down your strength, weakness, opportunities, and threats. And then later on, we are going to try to do the matching. Each is going to be like an individual piece of work. Ultimately, basically, just to let you know about the strength, people tend to work on their weaknesses. Okay, I have these weaknesses. I'm going to focus my effort, my time, my money, and so on weaknesses, trying to convert weakness into strength. But basically, this is not how things should be done. Basically, we need to spend 80% of our time and effort on our strength. Okay, strength which matches opportunities. So we need to focus 80% of our time and energy on that. Then we need to have like we are going to use the 80-20 rule, that is a Pareto principle. So we are going to see we have a few weaknesses, but we can't focus all our time on weaknesses. We are going to select 20 of these, like 20% of these weaknesses based on opportunities and threats which we have in the external environment, which we need to convert. We need to work on these weaknesses. Maybe not convert that into strength, maybe just convert that into neutral. So it's not my weakness, not my strength as well, but I do have part of these skills. So this is how we are going to do things. So this is like a young guy, some 16, 15, 16 years back when I joined the power system, the utility. So I just came from the university. Actually, we got job, my batch got job even before graduation, even before leaving the university, we had to apply. But it was like not few, but 15, 16 years back. So when I joined the Central Electricity Board, full of ideas, wanting to innovate, new things coming up, you just like your pump, you just came from the university, you have been doing well. It's like, and then we joined with a group. It was like, I think 10 of our class who joined the Central Electricity Board. And then we were trying to see, okay, but why don't we do that? Why don't we try that? Then a principal engineer called me. He said, don't try to change the CB. The CB is going to change you. So this was a blow to me, okay, because I had so new ideas, but for them, things have been working well for them all that time. She was maybe 20 years of experience, 40, maybe 30 years of experience. Things have been working well. So why change? Remember, in terms of the characteristic of Gen Z, what I mentioned previously, they embrace change, they like change, they want to have change, and they are going to easily adapt to change. But the previous generation, they didn't want to have change. I was in the middle as a millennial. I wanted change, but then I was like, it was a barrier. There was a huge wall, a barrier to these changes. And there was another principal engineer who told me, the power system is not going to change. So this was like 15 years back. We are going to have our transmission towers, we need transformers, we need the generators and so on. We can't do without that. It's not going to become wireless. So things are going to remain as they are. But nowadays, we are going to show you how things are changing. And if we don't adapt, we are going to die. Okay, so don't get into this same issues that I've got when I joined the CEB 15 years back. Things are actually changing, and you have these skills. The university is already training you to have such skills to be able to adapt easily to the new power system. Let's start with the first one. Okay, we are starting with the generation that we have. So initially, the generation was centralized. Nowadays, we have what we call the distributed generation. So like what is meant by distributed generation, instead of having centralized power plant, we can have maybe PV or wind injected on the distribution network, like 22 kV, or even the customer. We are going to introduce the customer later on as no longer the customer, but the prosumer. Okay, he's going to produce as well. So he can install a rooftop PV and maybe export excess power he's generating to the grid. Okay, so things has started to change on, like, remember what we draw? Let me just put that first. The power flow initially it was unilateral from top to bottom. Nowadays, it can have even reverse power flow. Okay, it's slightly different, but with so much of consequence behind. The data flow as well, it was unilateral, maybe generation to transmission. Now it's coming even to the distribution level. Maybe if you have a PV plant which is connected to the 22 kV network, you will need to understand how much power is being injected, what is happening to this part of the network. So you will need to collect information, okay, collecting information. So we mean sensors installed on the network, a communication system to get all these information, all these data to a maybe centralized part office. Now imagine how many of these distributed generation we are going to have around the island, maybe lots. So it's going to be like an inflow of information, okay? Like what we call lots of data. How are we going to manage such data? Okay, things are going to start working out for you now. Okay, payments as well. Since you are exporting to the grid, there may be some tariff which are introduced where you're going to be paid. Instead of you always paying the utility, you may be paid nowadays as a consumer, or what we call the prosumer. So you will see that the power flow has changed, the data flow has changed, as well as the payment. Okay, and we see that the system is not only it's not only the utility which is going to be like a party or a big player. We are going to have different, maybe not owners, but different stakeholders in the energy arena or in the energy market or whatever we are going to call that. Next, let's say we have lots of these renewable energy. We need to plan for these properly. So what is planning? Initially, how do we plan actually for when we have the centralized power plant? How do we plan for maybe how much of generation? As you may be knowing, demand and supply needs to be like in equilibrium, okay, throughout the power system, okay, like 24 hours, 24/7 basis, this should be met. But ultimately, when you are having, it's easy when you have like a centralized power plant, a diesel power plant, to say, okay, let's put 20 megawatts on that. That's okay, it's going to be firm power. But when you have wind, when you have solar, you need to predict, you need to be able to say, okay, I have a 10 megawatt wind farm, but how much power can I expect to have over the next 1 hour or tomorrow? So you need to have prediction, you need to have forecasting, and for that you will need to have lots of forecasting model, data input, okay, maybe collection of data over years, then collect information from the site, okay, and then put all that together, work on a forecasting model to be able to predict. Then it's going to be like learning stage as well, okay, it's going to learn from its mistake, it's going to optimize with time. So these are optimization scheme which you maybe are learning about and which need to be implemented. In terms of the power grid management, it's no longer like I'm calling it easy. It's not easy, but as compared to what's coming in the next few years, couple of years, things are going to change. We need state-of-art computerized control centers with associated telecommunication system. Okay, quick optical communication is no longer like microwave or what we have been using previously. It's optical communication and adapted substations, equipment. We need to install equipment everywhere on the network, maybe on pole, on transformers, and even the customer. Remember, he's called a prosumer nowadays. He's going to have like a smart meter where you will know what's happening. Is it exporting? Is he importing power? And all that needs to be recorded, maybe in real time. And then you need to have a database to be able to hold all that huge amount of information. In terms of the power system, I'm just going to mention a few terms. It's going to be converted into, maybe you are going to have parts which are going to be virtual power plants. Okay, I won't have time to maybe spend on explaining to you, but if you're interested, you can read about virtual power plants, microgrids, and then we have active network management. I'm going to have one slide on active network management, maybe just later on, just to explain maybe a new term, and we are going to see how it is changing the landscape. So as we said, it's going to be like an energy marketplace. People are going to be here, maybe you are going to export, you want to sell, you may even have peer-to-peer selling. I want to buy electricity from my neighbor. He's getting electricity from PV, and I want to buy from, I want clean energy as a maybe new generation. I'm concerned about sustainability, clean energy. I want to power my house with clean. I don't want, I can't install maybe a PV plant, but I want to buy clean energy. I'm even willing to pay more for that. How are we going to do that? This becomes complicated. This becomes complicated because you have a choice. And then, but with a law, so it's not only like physically or technically, which this is going to happen. We have the law is going to be like a regulator which is going to come into place. It's about maybe the electricity regulation, electricity act, and so on, which needs to be changed. It's going to take time, but it is happening. I think in the UK, it is happening in several places around the world. It is happening. So you're going to buy maybe credits. You're going to buy maybe, how are you going to pay for these? Nowadays, you have maybe a structure where you have a meter which is going to collect what is being exported, what is imported. You can do the net calculation. But then if you are willing to buy from someone, you can't put a wire or a cable connecting you to, or you want to buy from your friend living in, you are in QPIP, you want to buy from MyBlue, but you're going to use existing grid, but it's going to have a system which is being developed. It's here. And at that point in time, power flow is still in two-way. Data flow is from the generation to the customer, end customer, and payment as well is like fully flow. So it's like it's not as simple as linear as it has been. So it's going to be much more connection. Actually, we call that, it's going to be like a wholesale market. Okay, it's going to be dynamic. We are going to have peer-to-peer trading. People can buy and sell with whomever they want. It's not going to be only you. I want to buy. Currently, we have only it's a monopoly. okay, where you need to buy from this central electricity board, your utility. It is like that as per the Electricity Act. But with time, as we are seeing in different countries, things are changing. So let's see where we have reached. So how are we going to control that? Okay, with the current maybe infrastructure, we can't. Okay, so this is how, this is maybe why, not how, why, but maybe which like technique, okay, is going to help us achieve that. So people, what is the research ongoing is about the blockchain technology. So emerging energy blockchain usage, so it's going to be used on 10%, what is say 10% in terms of metering, 20% on grid management, 40% on centralized generation, 20% on electric vehicle charging. We are going to come to that, and then 10% in terms of IoT. Okay, and what is research, current research is that it is already like 27 and 2018, they are already trying to adapt the blockchain technology to this type of transactions, the energy market transaction. They are already trying to adapt these to the changes which is happening in the energy market in the power utility field. So as I was telling you, I know I've been working for the maybe power system for the past 15 years, but when it comes to blockchain and so on, so I know what needs to be done. I know about the output, but I don't understand fully what's happening in this blockchain technology, what is happening behind the scene. But for you, as youngsters, you have understand that you have been introduced to these topics, and these are going to help you integrate. You're going to be the missing link in where we are in the power system, and what is a future power system. This future is not far away, and how are we going to adapt? And you're going to be the missing, you're going to fill in this missing link. So these are things that you need to start maybe looking at if you want to maybe join the power system sector. We have the electric vehicle charging. So as you know, we can't store AC power. We need to convert that into DC. So for that, we need to have battery for storage. Nowadays, we have not a lot, but around the world, the UK has already have regulations to limit maybe the amount of petroleum cars which are going to be on the road. So they are moving towards electric vehicles. In Mauritius as well, we have some rebate when you're going to buy electric vehicles in terms of duty. So what is the strategy? Okay, we have like the load demand actually is varying. As you can see, it's varying. Maybe it's going to be a hole, or let's call that and then it's going to go towards a peak, then it's going to go towards a fall. So these two in blue are going to be like off-peak hours, maybe at night. And then what is shown as a peak, which is in green, this is a peak maybe during the day, people are going to work and so on. Okay, so what they need, so this is complicated, not complicated, this is expensive to run a power system like that. If you're having different peaks and so on, okay, it's going to be expensive. You need to run specific engine. Okay, and the unit cost is quite high when you have peak. So they can shave the peak. Let's say at night, okay, maybe you have come home at 5 and you won't be using your car. You can just plug it in. And then when it is like a peak at 7 p.m., the utility, instead of putting new generator on, they can get power from your car. And then at night, 1 p.m., 1 a.m. in the morning, okay, no one is going using electricity. So the load on the grid is low. So it's cheap energy. So then this energy can be given back to recharge your car. So they are working on some principles. I think I have shared a few links. No, it's not on this slide. I have it. So this is a link. If you want to access such information, you have it. And then let's say you want, nowadays, let's say we don't know exactly, there are some people who know, we have this peak and off-peak hours and so on. People don't understand what is off-peak and so on. But for the utility, it is a huge problem. Okay, and let's say if we are able, okay, to do like a demand side management, we say, okay, people are not going to turn on the washing machine at 7 o'clock, but they can turn it at 8. So with IoT, Internet of Things, they can communicate with different devices to have like, okay, maybe a washing machine are going to be switched on during the off-peak hours. So they're going to bring down the peak. Okay, so this can be done only using IoT. Like, else is going to be much more complicated. And as you are seeing, you have so much of technologies getting in, and the system is no longer like a simple system like we have drone generation, transmission, distribution, customer service. It's no longer a linear approach. It's going to be more of a web. Okay, this is how things are going to be. You are going to have the physical layer. Yes, we need the transformers, we need the power lines, we need the generators, and these are going to remain. Then new things are going to pop up. You have the charging, you have the renewable energy, and so on. The battery as well. We did discuss about battery, okay, to store like huge amount of battery to store like energy and to maybe make up for the variation, okay, intermittency in renewable powers that we are having. So you're going to have the physical layer as it is, and then you will have on top of that a cyber blockchain layer, which is going to handle all that amount of information which is flowing, and maybe through programming and so on, you are going to be able, it's like a web, it's not like linear, and it is like a topic in itself that we will need to develop. And with that, okay, lots of security issues are going to come up. Well, we're going to have what we call cyber security threats. So you will need protection to your network, like people can get in and maybe change things like that. It can corrupt anything. So you will need to be able to have some like maybe protection for your system. And just for, I think I've seen that you have the QR code if you want to access. It's going to create, this renewable energy is going to create directly or indirectly lots of jobs, even for women. Okay, like initially power system was mostly a male dominant area. Okay, because you need to go on site, you need to be on pole, go on mountains and so on. So it's quite like a male dominant area. But nowadays with renewable energy, where you need not be on site all the time, you can do so much of work, not so much of it, but the works which need to be done on PC in an office area. Okay, these are, I'm not trying to create like a discrimination between male and female, but physically, okay, I've been on mountains in areas where you don't have network coverage and so on. It's not easy even for us, but just imagine for a girl to be on mountains, and so it's not easy. Okay, so things are going to work out for you as well. And based on research, you are going to see that this is going to be like a new arena, a new maybe avenue for students, for women, even for boys, okay, to get new jobs. Okay, automation is coming in, okay, to maybe people say to reduce jobs, to cut down jobs, but new jobs are being created in this field as well. No, so this was a part where we were discussing about the generation part. Now, in terms of the network, remember the transmission and distribution network, things are changing as well. We are going to discuss only a few because we have time is limited. Operations of the operation section, which look after the lines, they are concerned with inspection. So when we commission a line, we need to do inspection to see whether everything is working, to do maintenance of extensive infrastructure. Actually, it runs over the island. Mauritius is fully electrified, so we need to do regular inspection. So how do we do that? Actually, we need to have a team running around and so on. At times, on one pole here, we need to go to have a river in between. Okay, you need to have another road to see the other pole on the other side of the road. Nowadays, with drone, things are going to be much easier. So it's going to be less costly, less time consuming, and you can have pictures as well in terms of quality. So benefits can be in terms of cost, time, and quality. Inspecting pylons, lights, and components for damage. So checking whether things are damaged or not. Monitoring vegetation. Trees are going to get onto your lines. You need to monitor that frequently. And you even have thermal camera for preventing maintenance. When there is a loose connection, this is where faults happen with vibration and so on in the network. Actually, bolts and so on, they will start to loosen, and this is going to create a hotspot. So with the naked eye, you can't see that. So these drones now, they are fitted, okay, with thermal images where you can easily see these hotspots and so on, and you can take actions before the fault occurs. This is what we call preventive maintenance. Now, we are going to take pictures, videos, and so on. We have such a huge amount of data getting in the office. It's about not giga, but terabyte of data getting. How do we manage that? How are we going to save that? We need to have like a database management as well. It's going to maybe link the different maybe pictures maybe for this transmission line, and then with time you need to see the degradation. This was what we did 1 month, so this is how it has degraded one. You need to be able to retrieve this data. So who's going to take care of this? Maybe infrastructure, the storage, the database behind that. Okay, so think about all these. And in terms of the plan, the plan that we have, initially, like previously, even before, maybe when I entered, I think they were using already digitalized when I came in, maybe previously, they were what you have on the left-hand side, the picture on the left-hand side, they were drawing manually. Things have not changed a lot. So they have only moved to digital. So you're using AutoCAD to just draw the plan. It's easier. You can, if you're making mistakes, you can change that much easier. But then this is not the bottom. This is not what we want. What the new system is asking us. Nowadays, we are talking about a system where we have an asset management. So everything is digitalized. We have all the network, all the parameters, what we call a geospatial mapping of all the assets. Okay, so we know about the parameters, what is a pole, what is an insulator, what is a type of conductor, everything is listed. What is a power flow? Is it overloaded or not? And we are getting real-time information from the field. Remember, we need to install these devices at different locations. And then we have a communications system in between to be able to get all these data and then use all these data to be able to put that on a monitor. Okay, it is being started, but we need people to work on that. It is like at a preliminary stage. Okay, I want more. Okay, I'm not going to go and gather all the information. I'm not going to set up the network. I don't know how to program all these things. Maybe as a user, as an end user, I want to see it on my screen. But as young engineers, those who are maybe good at programming, I don't know what you're going to see, how to do the site survey, and so even site survey, they don't use theodolite and so on. With the drone that you can have LiDAR survey, and you stay in your car. The drone is going to go around this area, and they're going to give like a 3D mapping of the area in HD quality. Okay, even the terrain, the topology, everything is given to you. So things are changing, and we need to adapt to this environment. So this is going to be integrated with GIS, mapping, weather conditions, smart metering, what's happening at the customer terminals, and so on. So everything. So it's lots of information that we call big data. And I think this is a term that you use, big data. But what's happening behind? It's a lot of technicalities and so on, which I'm not used to. Maybe I won't step into. I don't want to step into all that. But maybe you have the solutions to that. And maybe you can access that from mobile phone as well. Okay. And let's have a look at another facet of networks. Okay. Here it is like a main line getting maybe supplying different houses and so on, the current infrastructure. And you have a tie line just below, which is used, maybe it is there, but it is open. Let's say you have a fault happening on part of the line here. Basically, nowadays, what's going to happen? You need to, these people living in the house, they will call the hotline. They will say, okay, we don't have power. So then maybe 1 or 2 people, 3 people calling, then they will know that, okay, we have an issue over there. They will call out maybe an engineer or a team to get on site. And so not an engineer, maybe to a supervisor and a team to get on site to see what's happening, what is the issue. Then maybe they will need to do the repair. Maybe they need to pick up other materials. They will need to look after all that. But now we can't afford that. People don't want to remain without electricity nowadays. Okay. So we are going to talk about network reconfiguration. Oops, let me just, so this line is going to be off. We are going to provide power through the bottom line. It was there, but it was off. So all these are done automatically. As soon as the sensor, you see you have different sensors on the line, they're sensing that in real time. They will know that this part of the network is damaged. There's a fault on this part of the network. So we're going to do network reconfiguration automatically within a few seconds. Okay, then the team is going to be informed, and then the team is going to take maybe 1 hour, whatever, to come to the site. This doesn't matter. At least the customers, they have the power. So we call that self-healing network. It's going to be robust. It's going to have automatic reconfiguration and a fault management system. It's not like we are waiting for customers to call us to be know about a fault at the bottom end of the line. If it is on the network, we will be able to know. We have sensors and so on. But if it is at the customer end, we won't be knowing. We rely on people to call the 130 as the hotline to be able to know. So we can have a much better fault management system to help our consumers. Remember, the traditional power system, we had reliability, security, and quality of supply. Nowadays, we are talking about response time. People can't live without power. Maybe without electricity, yes, but your Wi-Fi is dependent on electricity. Your water pump is reliant on the electricity. Maybe you can't even go to the toilet, okay, if you don't have a proper, maybe water pump and so on. So everything is reliant on electricity. So response time is going to be improved. Frequency and duration of interruption are going to be reduced. The fault, if there's a fault, is going to happen, but then the network is going to reconfigure automatically within a few seconds, and people won't sense maybe this, like staying without electricity for 5 minutes as compared to maybe a fraction of a second. So this is how things are. So it is an infrastructure which needs to be installed, to be developed, to be able to work from scratch. Okay, so these are the new things which are happening in terms of the network. I'm just going to cover the active network management. If you have maybe high winds, if it is close to, you have a network which is close to maybe a wind farm. Okay, so high winds means high power output from wind turbines. Okay, high winds, it's going to be tantamount to extra cooling. So the conductors there in this area, the high winds is going to be more power from the wind turbine. So extra cooling on the conductors as well. Extra cooling means extra transmission capacity. You will know that the resistance is dependent on temperature. Okay, so since it is cooler, not cooler, but it is windy, the temperature is going to be cooler. So you can expect to go beyond maybe the design transmission capacity. Okay, so we work on dynamic line rating. So low ambient temperature means extra transmission capacity. So you can increase your transmission capacity. So you need, for that to be able, nowadays we can't do that because we don't have data, so much of data. Okay, we need the data in real time, and it may be a system to be able to interpret, to gather, to collect, to present all these data in an effective way. Okay, so these are the types of devices which needs to be installed on the line to be able to get back all these data. So we call active management dynamic line rating. This said, we are still going to need our transformers. We are not going to need only like soft power engineers to work through all that, but we'll still be needing these engineers who are going to work on transformers, those who needs to go onto the power. So on the left it's me, but on the right it's not me. Okay, it's another picture which I've taken, I think, from China. So we will still be needing these traditional engineers and workmen. We'll still be needing our linesmen to go on pole to do the repair works and or to do the installation work. But then let me just I think we have a few 5 minutes. I think we can watch. We have 2 videos remaining. Let's go through these. This is the future work. We have seen that these are going to stay, but let's have a look at what the future looks for us. Let's have a look at this second video before finishing.
The city of Toul has one of the most modern combined cycle power plants in France. Celeste has not only commissioned Siemens to build this plant, but also to operate it under an operation and maintenance contract.
There's a will in any plant operated by Siemens service to provide the best efficiency. So we are operating the plant of Toul as if it were our own.
What if we have a completely digital chain from collecting data, evaluating data, and post-processing of data? My opinion is that augmented reality can help to achieve this. That's my vision.
Siemens uses professional-grade augmented reality as a versatile tool for the digitalization of power plant services during operation, as well as for staff training.
I think is going to be a great component for our training for the operating and maintenance centre. It's going to expand our portfolio and be able to train on site. So you've got operators training locally via the augmented training.
It's a very amazing experience. Well, actually, it's very simple to use.
Well, Welcome to the Siemens Operating and Maintenance Training Program. You're ready to start your first training session.
Trainees can familiarize themselves with the processes in the power plant step by step by using virtual work instructions, prepared training sequences, or remote assistance directly from a trainer.
Well done. You passed the first part of your training.
Well, it was like a new world full of technology and innovation, a new way of life.
The DACRI Smart Helmet can also be used as an intelligent solution in operation and maintenance. A big advantage, the communication with the Siemens SPPA T3000 control system is possible. For allowing digital measurement and operating data to be immediately available wherever they are needed.
Avec le casque d'Acri, l'avantage c'est qu'on pourra travailler les mains libres et je pense que c'est vraiment le futur de l'industrie de travailler avec ce type de casque.
The operation engineers use the helmet as an on-site information tool and can communicate directly with colleagues in the control room via remote expert.
Pierre, pour la salle de contrôle.
Oui, Pierre, je t'écoute.
Alors, j'attends l'instruction, je suis au centre de conteneur.
Tu peux ligner pour la partie HP.
Bien reçu, je commence les réglages.
Je te remercie.
C'est très pratique d'avoir la fonctionnalité thermique directement intégrée au casque. Ça, pareil, ça évite d'avoir à retourner à l'atelier pour aller chercher le matériel, pour aller faire ce relevé thermique.
Digitalization is not the future, it's the present.
Siemens is driving digitalization on all levels, and augmented reality is one piece in this game, definitely.
Okay, so basically this was how the new maybe power system is going to look like and how you need to remember in our first when we were speaking about the Gen Z, you have one small girl with this virtual reality, maybe Google in her eyes. This is what's happening. We are going to implement that in power system as well. So it is new technology, just like in new car, you have auto parking, lane assist, maybe collision avoidance. We are going to use these as well in power system. By now, I think we have less than 1 minute remaining. Maybe we'll need to reconnect. This is the last part of the presentation anyway. We just reconnect after 1 minute of when this presentation is going to stop for the question and answer session. And maybe we can have like a vote of thank later on. So you will need to know what are your strengths, weakness, opportunities, and threats. We have seen what are the opportunities, what are the threats, but you will need to, okay, as to that, know what are your strengths, what are your weaknesses to be able to fit in this new power system. So it is a modern power system. And then as Gen Z engineers, you will be able to fit in this new power system. So this is it. I think we are going to be disconnected and then we can just join on the same link again to handle maybe a few questions which you are going to have. Good. So see you in a short while with the questions.